I'm good to go to check the accuracy of bevel stops on a compound miter, so I made adjustments and I want to make some test cuts. And I'll show you how and why the test cuts work. Come take a look what's here on the saw table here. We're going to use some geometry, and let me explain how this is going to work. In geometry from elementary school, you know that if we have a line A, and on line A at point at point X, we draw a line segment like so. We just created two adjacent angles. One would be an acute angle, and the other one, the biggie one, is the obtuse angle. And because these adjacent angles are on a straight line, the sum spelled that way, the sum of the acute and the obtuse angles will be exactly 180 degrees, because 180 degrees is half a circle, and there you go, one straight line is or could stand in as a diameter of a circle. So an acute and an obtuse supplementary or adjacent angles are 180 degrees. We are going to use this idea here for the next bit of geometry that I have on this paper here. You've seen this one as well in elementary or middle school, that two parallel lines intersected by or transversed by a transverse line will create a bunch of angles that some of them are similar. This will be an acute angle, and this will be an obtuse angle there on that side of the parallel, that side of one of the parallel lines where the parallel and the transverse intersect. And we know that this angle here will have exactly the same size as the adjacent angle up here, and this obtuse angle will have the same angle as this obtuse will have the same angle as this one there. And how this is going to work with the test cuts is that I have here a piece of cardboard cut. This is going to be our wood. This is going to be standing in for a piece of scrap wood with which we can verify the accuracy of our bevel stops. Say, let me just put it here this way so you can see. Okay, this is two parallel lines here, and I intersected it with a transverse line there. The intersection was done by a pair of scissors. With this geometry layout here, we know that this angle here is just as big as just a sec. Let me just extend this line here a little bit here and a little bit here, so it makes more sense. So this angle here is the same size as this angle here, and we also know that this angle here has the same size as this angle here. Okay, and this one and this one add up to be 180 degrees. Come on in closer a little bit. There. This acute angle and this obtuse angle add up to be exactly 180 degrees. And if we have an acute angle here and an acute angle here, and we have an acute angle here, we also have an acute angle here. Consequently, if the acute and the obtuse here add up to be 180, an acute and an acute do not add up to be 180. Now, how is this going to work? There's the two acute angles. This acute angle here on this part of the cardboard here is exactly the same size as this acute angle here, okay? It's the same thing, just on the other side of the cardboard. You see that acute angle there? It is the same as that acute angle there. So, to make a test cut, I'm gonna cut a piece of wood with two parallel edges along one line, and I'm gonna flip only one of the boards, and by only one side of the now two halves, and that way two acute angles will rotate to be adjacent angles now. And we know that the two acute angles do not ever add up to be 180 degrees. So therefore, if they don't add up to be 180 degrees, and I grab this, zoom out a little bit, but you can see it's a combination square. I grab this combination square and I put the piece of wood along the edge of a combination square or any kind of straight line. We will have a gap. We will have a gap here. See where my finger is pointing? We're gonna have a gap here. If this edge here is gonna be straight and these two are acute, then it makes a gap here. These two have to be exactly 90-degree angles to not have a gap here. Okay, so I hope that's making sense. And what do you know? I already have a piece of wood here that I cut, and I marked the front on it. Oops, sorry. I marked the front on it, so when I rotate the pieces, I know exactly how much to rotate, because 90-degree rotation is not gonna be enough. I need to rotate exactly 180 degrees. So what I'm doing is, I have an acute angle here, maybe in theory, and another acute angle here, and since I have an acute angle there, I must have the same on the back side. And if I rotate these two acute angles side by side, if this cut is not exactly 90 degrees there and 90 degrees there, there's gonna be a gap here when I check it with a straight edge. So let's see what we got here. I rotated it around, and let's see how my pieces check out with a straight edge. I'm gonna grab it so you guys can see it. Whoops. Thereabouts. You can see that the square is tight against the wood here. There is no gap between the blade of the square and the edge of the wood. So the piece is straight. And on this side, do we have a gap there? Nope, I don't see no gap. No gap there. So therefore, I can verify. I'm just waiting for the camera to focus a little bit. I can verify it this way, that this piece is straight. Okay, ideally, in a shop, you can do it in a way that you don't have to work around the camera, but you kind of get the idea. There, I can't hold it in one hand to have you see it, but you get the idea. I did the same thing with the 45-degree bevels. I'll show you how they look like. They are going to be a little bit different. Now, what do we have here? I have a piece of wood that's marked for the front side, and I checked with it the left 45-degree bevel stop. What I did was tilted the saw, and this was cut in this position. If this one is a 45-degree angle and this one is a 45-degree angle, when I rotate the two acute angles side by side, the two 45s must make a square corner here. And that square corner can be easily checked by this combination square, something like that. And let's see what we've got here. Do we really have a 90-degree corner here? Let's see. I say we don't. It's out. The stock of the square here in my left hand is tight against the block of wood, and when I try to close the gap, I can't. There's a little bit of light showing through here. It's not possible. When I make that little light disappear here, I just open the gap here between the two wood blocks. There's no gap here where my thumb is holding the wood there, but if I make these two pieces of wood tight against both the stock and the blade of the square, there is a gap here and you can see light coming through it. Consequently, my bevel stop for the left 45-degree angle is incorrect. It needs adjustment. I made another test cut for my right 45-degree bevel, and this is how the piece of wood looked like. And again, when I rotate this piece, the two acute angles must form 90 degrees here. So let's see how that fares. I'm gonna set my square this way and check it this way now. Hold the pieces there together and let's see how we look. That's pretty close there. We have a little bit of a gap here as well, but I'm wondering, and this is why you need to start with a straight piece of wood in the first place. I'm suspecting that this piece of wood, these two sides are not parallel, and I'm gonna check my suspicion with the same square just to measure the outside of it, like we did before. There, let's see, what do we have here? Yeah, that's pretty impeccable there. It's tight against here, against the stock of the square, tight against the blade of the square. Alrighty, it's just my piece is slightly tapering. That's why it didn't work perfectly on the inside. So, but you can see that this corner is a 90-degree corner. So that's how you can check your bevels and your bevel stops on your compound miter. So, and I do recommend that you don't start cutting compound miter where a miter angle might mess up your measurements or your lines of sight, and just instead just do a square cut, do a left 45, do a right 45, and just test one thing at a time, okay? So that's how you do it.